In lesson 5.5, we're going to go through the steps of a hypothesis test with two different data sets to see if there is a significant difference between two means in the data set. And just to kind of review the process that we've used in the past to complete a hypothesis test, number one, we want to state our hypotheses. We start with H naught or H sub zero, which is what we call our null hypothesis. And this is always a claim that there is no difference in an athlete's or a team's ability in two different contexts. The other claim, H sub A, is what we call our alternative hypothesis. And this is a claim that an athlete's or a team's ability is greater in one context than another. Step number two, we want to find our test statistic. This is a measure that we calculate from an athlete's or a team's performance. And with different types of hypotheses tests, we've used different types of test statistics. And in this one, we're going to be using means. Step number three, we want to conduct many simulations of the situation, assuming that there is no difference in the ability from one context to the next. And we've done simulations in lots of ways, including with cards and random digit tables and with applets, and that's what we're going to use in this section. So I'll be showing you a new applet. Number four, we want to use the test statistic to find the p-value. The p-value is the proportion of the simulation results that are equal to or more extreme than our test statistic. So we'll count up our dots. And then number five, we're going to make a conclusion. So if our p-value is small, meaning less than 5%, we reject our null hypothesis. That gives us good evidence that our alternative hypothesis is true. If the p-value is 5% or greater, then we reject or fail to reject our null hypothesis. That means that we do not have good evidence that our alternative hypothesis is true. So we're going to look at our putting data again. Here we have John using two different types of putters in an experiment to test whether the long or short putters were more accurate. The distance that the golf ball landed from the cup is shown below, along with dot plots for the two putters. So I've looked at this data a few times throughout the chapter. And we've talked about the shape of the distribution. We've done 5-number summaries and all kinds of stuff. So let's go through the steps of our hypothesis test. So first, let's write our null hypothesis. We would say John has the same putting ability with the long and the short putter. We assume that his ability is the same in both contexts. And in this case, our context is the two different putters. Our alternative is that John has greater putting ability with the long putters. That's what we're assuming is true based on the data that we've looked at already in this chapter. Now we're going to calculate our test statistic. In this example, we are using a difference in the mean distance for each putter, and they're telling us to subtract short minus long. So we're going to calculate the mean distance for the short putter and the mean distance for the long putter. So when I calculated the mean for the short putter data, I got 25.7. And for the long putter, I got 21.4. And remember, we're measuring the distance the ball lands from the hole. So in this case, a smaller number is better because that means his putt was closer to the hole, so it was better. So short minus long, the difference in those two means would be our test statistic, which in this case is 4.3 centimeters. Now I've given you the results already of the simulation, and what we're looking at here is simulated difference in means. And our test statistic, remember we calculated, was 4.3. So we're going to, on this scale, try to identify about where 4.3 is. It would be somewhere between 0 and 10, and it's really hard to tell because it's not really precisely labeled, but that's okay. But anything 4.3 or greater would be our p-value. Because that would be stronger evidence that one putter is better than the other. If the difference in those means was really, really big, we would know that one putter was better than the other. If the differences are close to 0, that means there's essentially no difference in the putters. And it's a little bit hard to tell the p-value on this one because we don't know exactly where 4.3 is, but we know that there's a lot of dots there, right? Whether we guess 4.3 is here or a little more over this side, still a lot more than 5 dots. When I counted those up, I got 45 dots out of 100. So 45 out of 100 gives us a p-value of 0.45, and that is much, much greater than 5%. So our conclusion then would be fail to reject the null hypothesis. There is not good evidence that John has greater ability with the long putter than he does with the short putter. Let's do a second example. Example number 2 says, is there a home court advantage in the WNBA? Below, we have points allowed during the 2008 season by the WNBA's New York Liberty. And so what we're looking at are points allowed, which means that teams that have play better defense, maybe they play better defense at home, for instance, would allow fewer points. So just kind of keep that in mind as we're going through this problem. Let's start by writing our hypotheses. The null hypothesis would be that the Liberty has the same ability to play defense home and away. Our alternative is that they have greater ability to play defense at home than away. And the reason we worded it that way is because the stem of the problem is asking about a home court advantage. So that leads us to believe that our data is going to show us that. Now we're going to calculate the test statistic. And in this case, I would put those two sets of data into my calculator and use the one variable stats function to find those means. So for away games, the mean number of points allowed was 79.3. In home games, the mean number of points allowed was 70.6. And the directions say to calculate the statistic doing away minus home. So our test statistic would be the difference in those means, 79.3 minus 70.6, which would be 8.7. Now we're going to do a simulation using the applet, and you will be provided with a link to that applet. And so I'll show you what that would look like. This is the applet we're going to use for it's a difference in means or medians. And notice that you have a drop down here, which should default at means. And for now, we're going to use that. And then in the next section, we'll change that to medians. But for now, we'll just leave it there. And then you've got boxes here where you need to type in the data. And you can either put those in with commas in between or spaces, but you're going to actually just type the data home and away into those two boxes. So I did that there. And then notice there's a button for calculate observed difference. So if you click that, it will actually give you the mean number of points allowed in each of those contexts, which we did with our calculator, but the applet will do that for you as well. And then the observed difference, 8.706, is what we got for our test statistic. They just went out to more decimal places here. So I want to simulate 100 differences in those means. And then we'll type in 100 and then click the add more trials button like we've done lots of times on our applets. And this is the dot plot that I got. Now, when you do this, you might get something that looks similar to that, but not exactly. And our test statistic, remember, was 8.7. My largest value that I got from my simulation was just a little bit below 8. Now, you may have gotten actually one or two above 8, but probably not very many. And either way, you can have the applet count the number of dots for you. So I changed this to count the number of dots greater than or equal to 8.7, and I clicked the count button, and it told me that none of my dots are greater than or equal to that value. So you can pause the video and go ahead and sketch your dot plot into your notes. And then once you do that, the p-value, of course, would be 0 out of 100 or 0%. So let's make our conclusion then. We would reject the null hypothesis, and that means that we have good evidence that the Liberty have a greater ability to play defense at home. Please do homework 5.5 in your assignment packet.